Okay, so hello everyone, and I'm going to start today's session right now. Let me share my screen. I hope you can see the screen. So let's start today's session. So this is assignment 6, previous year assignment 6 questions, and this is the topic nuclear and particle physics. So let's start. The first question is, which of the following interactions are not influenced by electromagnetic interactions? So and there are 4 options like E plus nu going to mu plus. Okay. So I think I should wait for some time, and after that I will start. Maybe people are coming. Okay, so the first question is, which of the following interactions are not influenced by electromagnetic interactions? It's already mentioned here that not influenced. That means we have to consider which among these 4 options which interaction or interactions are not influenced by electromagnetic interaction. I think you have already known that how many interactions are there. Like there are 4 interactions basically, like 4 fundamental forces are there. That means one is gravitational force, another one is electromagnetic force, third one is weak nuclear force, and fourth one is strong nuclear force, right? So among these 4, they are asking, in that first question they are asking which interactions are not influenced by electromagnetic interaction. So we have to know about electromagnetic interaction at first a little bit more, and after that we can answer these questions. These options we will see. So for electromagnetic interaction, so that electromagnetic interaction is governed by basically Coulomb law. Okay, and you have heard that in that Coulomb law, what is the Coulomb law? Like 1 by 4 pi epsilon naught, then q1 q2 by r square. It is a very simple Coulomb law. So for that you can see that there are like q1 is the charge of that particle 1, and q2 is the charge of the particle 2. So that means whatever the wherever the electromagnetic interaction will be there should be one charged particle, right? So in that expression you can see that all the options are basically charged particle. That is fine, no problem. And also we have to see that electromagnetic interaction is mediated by photon. It is mediated by photon. So whenever we can see in any nuclear interaction that photon is producing as a byproduct or as an outgoing particle, or proton can be a mediator in that nuclear reaction. This nuclear reaction, obviously it will be electromagnetic interaction. So in that expression for the case 1, E plus nu, so there may be a confusion with that notation of nu and gamma. This is nu, it is going to mu plus and nu. So you can see that there is nothing as gamma, like it is also not mediated by gamma, or the byproduct is not a gamma particle. The photon is not producing in that interaction. So maybe it is not a electromagnetic interaction. But here you can also see that E plus E minus, it is going to mu plus mu minus. This is also not mediated by gamma, as well as the byproduct, that outgoing particle is also not gamma. And this one you can see E plus E minus, gamma gamma, right? So this will obviously, definitely it will be a electromagnetic interaction. Okay, now you can see, you can ask me that E plus E minus going to mu plus mu minus. Okay. So you can ask me that E plus E minus going to mu plus mu minus, that type of interaction might have mediated by gamma. So obviously it is mediated by gamma, because there is nothing as a, like you can see that E plus E minus, mu plus mu minus. So there is okay. So for that interaction, whatever it is in B, and for that interaction whatever it is in C, these two are electromagnetic interaction, because in that C equation the outgoing particle is gamma, it's already we can see, and for B the mediating particle is gamma. And I have told you that whenever the mediating particle will be gamma, that will be definitely a electromagnetic interaction, or the outgoing particle will is gamma, then also we can have a EM interaction. So the main point for that electromagnetic interaction, magnetic, to know that this interaction is electromagnetic interaction or not, we have to check that it is mediated by gamma or not, or the outgoing particle is gamma or not. So as the first question, we can see that B, option B and option C. In option C the outgoing particle is gamma, obviously we can see, and for B we can have the mediator as gamma, because this is also a charged particle, this is also a charged particle, this is also a charged particle, and this is also a charged particle, and this should be mediated by gamma. So that means as a whole B and C can have the electromagnetic interaction. So that means which of the following interactions are not influenced by gamma? This one will not be induced by gamma, and this one will not be induced by gamma. Why? Because you can see in that A and D the outgoing particles are nu. Nu means neutrino. So whenever in any nuclear interaction neutrino are the outgoing particle, or neutrinos are produced in that nuclear reaction, that will be definitely a weak interaction. Okay. So to know that is it a weak interaction or electromagnetic interaction, that is a very simple thing. If we can see that as an outgoing particle there is neutrino, then it is definitely a weak interaction. And if there is outgoing particle as gamma or photon, then also it will be definitely an electromagnetic interaction. So by seeing the outgoing particle, what is outgoing particle in that nuclear interaction, we can confirm that is it electromagnetic interaction or weak interaction. Now one can also ask me that, like, if there is no neutrino coming out from that interaction, then also we can have some result of weak interaction. That can also be possible, but the reverse is not possible. Like whenever neutrino will be there, that will be definitely a weak interaction. That is always happening. Okay. And whenever the gamma is produced in that nuclear interaction, that will be always electromagnetic interaction. So these two will be a main point or bottom point of from this first question, you can see. So for electromagnetic interaction, gamma will be present as outgoing particle, or gamma will be as mediator. So this is the this is for electromagnetic interaction. And for weak interaction, for weak interaction neutrino, any type of neutrino, it can be nu e, it can be nu mu, it can be nu tau, any type of neutrino, or then their bar, I mean that antiparticle, any type of neutrino can be produced. So neutrinos are produced. So to know very quickly that is it electromagnetic interaction or weak interaction, we just want to know that what is the outgoing particle for that nuclear interaction. Okay. So now coming to the second question. So from that first question we can have that the question number, the option A and option D are not electromagnetic interactions. Okay. Now coming to the second question. In that second question they are asking that pi minus going to mu minus plus E minus plus E plus. This type of nuclear interaction is there. Okay, first of all I want to tell you that whenever in any nuclear interaction it is written like mu minus E plus, that is nothing but the summation of this one. Okay, that means mu minus plus E plus. That is a short form of this plus thing. So as an outgoing particle mu minus is there, E minus is there and E plus is there. So as a short notation we can write mu minus, E minus and E plus. Okay. So now the question is pi minus going to mu minus, E plus. That is this decay is not possible because of there are 4 options are given. So for that question, first of all we just want to know one thing. I am just going to write this one again. This is the interaction, right? So in any nuclear reaction we have to know one thing, that baryon number, lepton number and charge conservation. These three, charge quantum number, these 3 quantum numbers should be conserved always in any nuclear reaction. Okay, that means in any nuclear reaction delta B should be 0, delta L should be 0 and delta Q should be 0. What is delta B, delta L and delta Q? Delta B means B initial minus B final, and delta Q is B initial L initial minus L final. Delta Q is Q initial minus Q final. Initial means the left hand side particles all the combinations, and the right hand side particles all the combinations is final state, right? So here you can see that if I am just considering here B, let's say, and the interaction is this one, plus minus minus. Okay, so for B we have to have delta B equals to 0, because this is a nuclear reaction and I told you that in any nuclear reaction B, L and Q should be always conserved. Okay, so you can see that pi minus is not a baryon, that means for pi minus it is 0. Mu minus is also not a baryon, E plus is also not a baryon, E minus is also not a baryon. That means as a whole if I write here B initial which is 0, B final which is also 0, that means for this case delta B equals to 0 is fine, it's conserved. Now coming to L. Okay, for L is nothing but the lepton number. So for pi minus lepton number is 0 because pi minus is not a lepton. For mu minus lepton is 1, lepton quantum number is 1. Right now I am talking about L means Le, L mu, L tau, as a whole I am considering as L. Which one is the lepton particle? That one we can have L as plus 1 and the anti-lepton will be minus 1 and non-leptonic particle will have L value 0. That is the thing. Okay. So for mu minus it is L is 1. For E plus what will be the value of L? L will be minus 1 because E minus is a lepton and E plus is the anti-lepton. So if I write here E plus has a lepton number minus 1. Now coming to the E minus has a lepton number what? It will be 1. So as a whole if I just add this right hand side terms, then what will be here? 1 minus 1 0 and then 1, that means as a whole it will be 1. Now you can see that if I write here delta L value, delta L I have told you that L initial minus L final. So what will be value? 0 minus 1 which is not equals to 0. That means our delta L is not equals to 0 which tells us that this nuclear interaction whatever I have written here pi minus goes to mu minus E plus E minus is not possible. Okay, and the violation is what? The violation in lepton number, not in baryon number, not in charge also. You can see that charge also. Charge is very simple. Charge also, if you want to see that mu minus E plus E minus. So for charge, this is minus 1, this is minus 1, this is plus 1, this is minus 1. So as a whole it is minus 1, and the left hand side was also minus 1. So that means our delta Q will be minus 1 minus of minus 1, that means 0. So charge is conserved, no problem on that. But the main problem is delta L is not equal to 0. That means the lepton number conservation is not here. So whatever it was the question that pi minus goes to mu minus E plus, decay is not possible because of non-conservation of lepton number. So the right answer will be C. Okay, I think it's understandable by all of you, right? I think so. Am I audible, right? Hello?
Yes, ma'am.
Okay, fine. Okay, so this is the question number 2. This is a very simple question. So whatever today we will discuss, these questions are very simple. Okay. So now coming to the third question. The similar question, the decay of delta minus goes to pi minus pi 0 is not permitted because of which? So I have told you that baryon, lepton and Q, these three should be conserved in any nuclear reaction. So let us first consider delta minus is going to what? Pi minus pi 0. Okay, pi minus pi 0. Let us consider at first Q value. Q value is fine because it is minus 1, this is also minus 1, this is 0. So as a whole, delta Q will be minus 1 minus of minus 1 plus 0, which is 0. So that is fine. Now coming to lepton number, you can see that delta minus is not a lepton, that means it has a 0 value. Pi minus is also not a lepton, pi 0 is also not a lepton, that means delta L will be 0. Good. Now coming to baryon number. What will be the baryon number for delta minus? For baryon number for delta minus will be 1 because delta minus is a baryonic particle, right? So in the delta family, how many baryons are there? Delta 0, delta minus, delta 0, delta plus and delta plus plus. There are 4 members in the delta family, right? So each and every one has baryon number positive 1. So baryon is positive. Baryon number for delta minus is 1. Now coming to pi minus. What will be the value for baryon number of pi minus? It will be 0 because pi minus is not a baryon. Pi 0 itself are not a baryon. So as a whole, if I write here delta B, then I can have 1 minus 0 plus 0, which is 1, which is not equal to 0. So that means for the expression delta minus going to pi minus plus pi 0, in that expression delta B is not equal to 0, delta Q is 0 and delta L is 0. So from that question I can write here that it is the decay of delta minus goes to pi minus pi 0 is not permitted because of non-conservation of baryon number. Okay, because our delta minus is not a baryon. Delta minus is a baryon particle, but pi minus and pi 0 are not a baryonic particle. Okay, so this is a very simple one, just like the previous one. Now coming to fourth question. Which of the following reactions are not allowed? Okay, so for not allowed and for allowed nuclear reactions, we just need to check these 3 things. Again I am just telling, these 3 things we have to just check: baryon number, lepton number and charge. So now first of all we will check each and every one. So let's say I have written here delta plus plus going to mu plus pi plus, mu plus pi plus. So whenever you will be used to on these 3 things, then you can simply say that by which in which term is not conjugate, so that it will not be conjugate. Okay, so from that interaction I can definitely tell that it is not possible because the delta B is not equals to 0 for this interaction. Why? In the left hand side delta plus plus is a baryon, and the right hand side mu plus and pi plus is not a baryon. These two are not a baryon. So obviously in right hand side it will be 0 and 0, and for left hand side it will be plus 1. So automatically we can say that this nuclear reaction will not be possible. Okay. So, but I mean, you don't need to check all the things for each and every interaction. If you have an idea that which one is baryon or which one is lepton, then you don't need to have any type of, like, we don't need to check each and every terms for all the interactions. Now you can see that for B it is 1, this is 0, this is 0, then delta B will be 1, which is not equals to 0. Now coming to lepton number, also you can see that the lepton number is also not conjugate here. So any one of these is not conjugate, that means our nuclear reaction is not possible. We have to conjugate all of the three for having a nuclear reaction possible. Okay. Okay. Now coming to L1. L1 also, L, for L you can see that delta plus plus is not a lepton. Mu plus is a lepton with lepton number plus 1, because mu minus has lepton number, sorry, this will be minus 1, because mu minus has lepton number plus 1 and mu plus is the antiparticle of mu minus, so the lepton number for mu plus will be minus 1, and pi plus is not a lepton number, a leptonic particle, so it will be 0. Then also you can have delta L equals to 0 minus of minus 1 plus 0, which is nothing but 1, which is not equals to 0. So that means our delta B is also not equals to 0, delta L is also not equals to 0. So both of these will violate our nuclear reaction, delta plus plus going to mu plus plus pi plus. Now coming to Q value is fine, like you can see that Q value is here 2, for mu plus it is 1, for pi plus it is also 1, so delta Q will be 2 minus 1 plus 1, which is 0. That is fine. But obviously delta B and delta L is not equals to 0, that means this expression is not possible. So the first one I have told that which of the following reactions are not allowed, that means this is not allowed, right? Now coming to second one, delta plus plus going to P plus plus pi plus, okay, delta plus plus going to P plus plus pi plus, and we have to check B, L and Q, these three are conjugate or not. Let us first consider Q. Q is a very simple 2, 1, 1. Now this is delta Q equals to 0. Now coming to L value. Delta plus is a lepton number or not? No, it is not a lepton, that means 0. P plus is also not a lepton, that means 0. Pi plus is also not a lepton, that means delta L will be 0. Now coming to B. What is B here? Okay. Yeah. So for B delta plus plus is a baryon number, that means it is 1. Now P plus is nothing but proton, okay. They have mentioned like that because it has a charge plus 1, that's why we have written here P plus. So proton is a baryon or not? Can anyone tell me proton is baryon or not? It is a baryon, okay. It is a baryon. So this has a plus 1 value. Now coming to pi plus. Pi plus is not a baryon, that means it will be 0. So now coming to delta B. Okay. So delta B will be 1 minus 1, which is 0. So delta B, you can see here that delta B equals to 0. So for that expression delta plus plus going to P plus plus pi plus, we can see delta Q, delta L, delta B all are 0. So this expression delta plus plus going to P plus plus pi plus is allowed. So I am just going to write here tick mark. for that allowed case. So B expression is allowed. Now coming to delta plus plus going to mu plus plus E plus. Delta plus plus going to mu plus plus E plus. Okay, B, Q, L. Q is 2, mu plus is 1, E plus is 1, delta Q is 0. B, baryon, delta plus plus is a baryon, mu plus is not a baryon, E plus is also not a baryon. That means delta B will be 1 minus 0 plus 0, 1 which is not equals to 0. Okay. Now coming to left-hand number. Left-hand number also for delta plus plus left-hand number is 0. Mu plus has minus 1. E plus is also minus 1. That means delta L will be 0 minus 1 minus 1. Then minus of minus 2 which is 2 which is not equals to 0. So from that expression you can see that delta B, delta L not equals to 0, delta Q is 0. But as delta B and delta L both are not equals to 0, that means it is not possible. The interaction is not possible. Now I am going to write here cross marks. Now coming to this one, delta plus plus pi minus pi 0. Delta plus plus pi minus pi 0. Again we want to see that B, Q and L. First of all Q, 2. For here 1. For this one minus 1. For this 0. Now you can see here that I think delta plus plus minus or what? Okay. Yes. So you can see here that obviously the right hand side is 0 and for left hand side it is 2. So that means delta Q will be 2 minus 0 which is 2 which is not equals to 0. So as we have seen that Q is not conjugate here, we don't need to calculate, check these two also. But like we are just for complication, for completeness I am just telling these things also. So for B, baryon number is 1 for delta plus plus, pi plus 0, pi minus 0, pi 0, 0. That means delta B also you can see that it is 0. It is not equals to 0. Now coming to lepton has no problem because delta plus plus is also not a lepton. Pi plus, pi minus, pi 0, these three of them are not a lepton number. So as a whole, leptonic particle. So as a whole it is delta L equals to 0. 0, 0, 0, then it is 0. So that is fine that delta L equals to 0. But the problem is delta B is not equals to 0. Delta Q is also not equals to 0. Delta L is 0. So as a whole this nuclear interaction is not possible. So how many nuclear interactions are not possible among these 4? A is not possible, C is not possible, D is not possible, not allowed. But B is allowed here. Okay. So among these 4, A, C, D are not allowed and B is allowed. Simple. So for that question we can have the answer A, C and D. Okay, up to now is there any question? Because we have already finished 4 questions. So if there is any question regarding up to this 4 question, we can ask me. You can ask me. I think no problem is there because these are very simple, like elementary particle are very interesting as well as very simple also. So should I move to the next question? I think it's better. Okay, now coming to the next question. This is question number 5. So what is this question? Let me check if I am audible or not. I think I am audible, right? Yes. Okay.
Yes, ma'am.
Okay. So coming to the question number 5. In that question number 5, choose all the correct statements from below. So there are 4 statements given, and we have to choose which one are which one or which 2 or 3 are the correct statements. So what are the statements here? Okay, just a minute. Discovered so far there will be a bracket. So here choose all the correct statements. So first one is top quark is the heaviest elementary particle known to us, and it is in bracket it is given that discovered so far. This is the first statement. In the second statement, baryons are made of 2 quarks. In the third question, under suitable conditions, electron and positron can form bound states. In the fourth question, gluons can directly interact with photons. Okay, there are 4 statements. So we have to check each and every one separately, and we will tell that it is correct or not. So first one is top quark is the heaviest elementary particle known to us. So how many quarks are there up to till now? There are 6 type of quarks. U, D, up quark, down quark, strange quark, top quark, bottom quark, and charm quark. Okay. So I think you have all knows these things. Like for Q value of this quark, it is like 2 by 3. This is 2 by 3. This is 2 by 3. E. E means what? Like 2 by 3 in unit of electron charge. So in electron charge, what is the electron charge? Obviously it is a 1. So that's why it is plus 2 by 3, plus 2 by 3, plus 2 by 3. Now for D, it is minus 1 by 3e, S minus 1 by 3e, and for B it is minus 1 by 3e. So these are the Q property, right? That is fine. The charge. But if I tell the mass, then what will be the mass for these 6 particles? Because in that first, statement, they are asking that top quark is the heaviest element. Heaviest means it has the largest mass among the 6 quarks. So let's ask about the mass of each and every quark. So if I write here mass of these quarks, then we can have a hierarchy like m of u is very very simple. Very very equal to m of d. It is also very very equal to m of s. But these all are very very small. Very small than m of s. Sorry, m of b, m of c, m of t. And among these B, C and T, m of T is greater than all of the above quarks. Like B, C, U, B, bottom, top, D, yes. D, up, down, bottom, charm, strange. Among these 6 particles, 6 quarks, MT is the highest one, and the rest of the things are lower than that one. So whatever is the first question, first statement, the top quark is the heaviest elementary particle known to us. This is correct one. Okay. Now coming, and it is written here that discovered so far, because like whatever we have known to till now, based on that we are just telling. It may be possible that after some time in the future we can discover one quark which is more heavy than top quark, then the statement will be different. But till now top quark is the heaviest elementary particle known to us. Okay, now coming to the second question. For the second question, what is the second question? Baryons are made of 2 quarks. Okay. So basically there are 2 so quarks. These quarks are basically formed two types of particles. One is meson and one is baryon. These 2 they are making. So about meson, what is the quark content for meson? It will be q bar, like that, and for baryon it will be like q. So the q is nothing but quark. Okay, so it can be anything, it can be B, C, D, U, S, T, it can be anything, but q bar is the general form for meson and q are the general form for the baryon. So if I write here that any type of baryon, let's say I am writing here neutron is also a baryon, proton is also a baryon. So you can see that the proton content is UD, and for neutron content is UDD. For omega is SSS. So this type of things, omega minus, these all are basically baryon, and they are made of with 3 quark q. In general, the notation for baryon is q. So that means whatever it is asking here, that baryons are made of 2 quarks, that is not correct. Baryons are made of 3 quarks, q. But if they are asking that meson is making as q bar. Okay, then we can say that mesons are made of 2 quarks. That is fine. Okay, so the second question is wrong. Now coming to the third option. Under suitable conditions, electron and positron can form bound states. Obviously, it is a true statement, because under suitable condition means if I have a suitable condition of energy, then and also it should be inside of a nucleus, then our nuclear circumstance, at that position electron and positron can form a bound state. So this is correct. Now coming to the fourth one, gluons can directly interact with photons. Okay, so for this I am just telling you something about gluon. Gluon is a mediator. Okay, gluon is a mediator for what? It is a mediator for strong nuclear interaction. So for that case, the gluons are basically self-interacting particle. That means it can interact with themselves. Like this is the notation for gluon. So gluon can interact with themselves like that. So you can see that this is one gluon, this is another gluon. So these two can interact themselves. That is possible. And also gluons are only exist inside the nuclear radius. Okay, so whatever they are asking in that question, gluons can directly interact with photon, it is not correct, because gluons can exist only inside the nuclear radius. So how they will interact with photon? So photon means it is outside of the nuclear radius. Okay, so but gluons can interact themselves, that is possible, but gluon cannot directly interact with photon. So that for this fourth statement is also incorrect. So choose all the correct statements from the below. I have told you that correct statements means A is a correct statement, C is a correct statement, but B and D are not correct statement. Okay, so I think it's already understandable. Now coming to the sixth question. In that sixth question, they are asking that E minus going to mu minus plus mu bar plus QE. This decay is not allowed because of which condition? Because of which quantum number or whatever. Why it is not possible? This decay is not possible. Why? So let me write here E minus going to mu minus plus mu bar plus E. So at the very first, what I have told you that we have to check B, L or Q whether these three are conjugate here or not. Okay, so at the very first I am just going to write here mu minus mu bar E. So first of all, B, baryon number. So E minus is not a baryon, mu minus is not a baryon, mu bar is not a baryon, E is not a baryon. So as a whole, delta B will be 0. Coming to charge, E minus has charge -1, mu minus -1, mu bar means it is a neutrino, antineutrino has charge 0, E is a neutrino which has a charge 0. So as a whole delta Q is also 0. Now coming to lepton number. You can see here E minus is a lepton 1, mu minus is also a lepton, nu mu bar is antilepton, nu E is lepton. So as a whole delta L is also 0. Now okay, so you can see here B, Q, L, all the three are conserved here. So apparently we can say that no, B, Q and L does not give any type of problem in that nuclear reaction. But in that question they have already mentioned that it should be a not allowed nuclear reaction. I mean it is not a possible nuclear reaction. Then we have to think more on that. What we have to think? First of all, we can also think that energy, right? Because energy can, I mean energy should be conserved in any nuclear reaction, not only any nuclear reaction, in any reaction the energy should be conserved, right? So what will be the energy conservation law here? Whatever the energy in the left hand side should be equal or greater than of the right hand side energies. So now you can see here that I am just taking these things, that interaction mu minus, nu mu bar, nu E, I am just taking this as in a rest position. Okay, so that means whatever the mass of that particle, that will be converted to the energy. So mass of E minus, we all know this one, which is 511 MeV. MeV. Now coming to m of mu minus, that is what it is, nearly 105.5 MeV. And also you can see that nu mu bar, nu E, they are very small particle and very massless, I mean very small mass particle, because like in standard model we have seen that neutrinos are massless particle, but as right now in our recent experiments we have seen that neutrinos can oscillate. So neutrinos cannot have a massless particle, I mean cannot have a zero mass, but it can have a very small mass. It is non-zero, but still it can have a very small mass. Small mass means of the order of electron volt. Okay, so I mean for this calculation, for right now we can neglect this mass, which is of the order of electron volt. With respect to other, they are very small, because you can see that this is MeV, this is MeV, and I am writing here this is EV. So it's a very small mass. Fine. So now you can see that in our left hand side it was in MeV. Which MeV? Of the order of 1 MeV. Like 0.511 MeV is there, that means of the order of 1 MeV. Now coming to here, what is this one? 105 MeV. And these two are very neglected, like it is in EV range. So you can see that the energy is not conserved here, because I told you that for energy conservation what we need, the left hand side particle should have a greater or very much equal mass as compared to the right hand particles. So in that right hand particle there are a very massive particle is placing, which is mu minus 105 MeV. But in left hand side you can see that on the only of the order of 1 MeV electron is present. So as even if B, Q and L are conserved in this nuclear reaction, we have to check that the energy is conserved here or not. So here energy is not conserved. So that's why we don't have this type of nuclear reaction. This nuclear reaction is not possible. E minus, mu bar plus nu E. This type of nuclear reaction is not possible because energy is not conserved here. Not conserved. I think you have understood this one. Now someone can also ask me one thing, that this type of reaction we can see in advanced level nuclear and particle physics. I mean I am right now telling that it is not possible, But in advanced level nuclear and particle physics study, if you see, then you can see that this is also possible. But how? Obviously energy should be conserved in any nuclear reaction. So let's say I am sending that electron with a very high energy. That means its kinetic energy is very high. Okay, and with that kinetic energy also the mass of its mass is included. That means as a total energy of that particle will be kinetic energy plus potential energy, which is coming from its mass. As a whole, the value of the total energy will be very large, so that the energetically problem, that energy is not conserved, that type of problem will not be there. So this type of expression will be possible only if we have a very high energetic electron and it is decaying to mu minus, nu mu bar and nu e. But in rest, if it is in rest, that means there is no kinetic energy, only potential energy. In rest, that type of interaction is not possible because energy is not conserved for that case. Okay. So for that question, E minus going to pi minus nu mu bar plus nu e decay is not allowed because energetic reasons. This is the correct answer. And also you can see that this one is I'm just writing here, it is a extra, you can tell. This is a weak interaction, right? If it is possible. Okay, let's say I am writing one expression which is possible. Mu minus going to E minus plus nu e bar plus nu mu. You can see that this type of nuclear reaction is possible. Why? Because it is not energetically forbidden. It is 105 and it is 0.511 and it is electron volt order. Then as a whole the energy is a little bit conserved here, so energetically there is no problem in that expression. But they are also so you can see that this is a weak interaction because in the outgoing particle neutrinos are produced. So we have to check, for this case we have to check Le, L mu and L tau, these three independently and separately, because in weak interaction each and every type of lepton quantum number should be conserved separately and independently. So let's say I have that type of interaction. This is an extra, like it is not given in your assignment, but I am just telling that if this type of interaction is there and we are checking that this type of interaction will be allowed or not, then beside of these three we have to check also Le, L mu, L tau separately and independently. If these Le, L mu, L tau are conserved separately and independently, then only we can say that okay, this is allowed interaction. Okay, so very quickly we can see that, just see very quickly, mu minus E minus nu e bar nu mu. Let us consider first Le. Mu minus has Le 0, E minus has Le 1, nu e bar it has Le minus 1, nu mu has Le 0. So you can see here delta of Le equals to 0, right? Because in the left hand side it is 0 and in right hand side 1 minus 1 0. Now come to L mu. Mu minus has 1, E minus 0, nu e bar 0, nu mu 1. Now you can see 1 0 0 1. So that means delta L mu is also 0. Now coming to delta tau. Mu minus delta tau 0, E minus delta tau 0, nu e bar 0, nu mu 0. So as a whole delta tau 0. Now you can see that from this picture we can have delta L equals Le 0, delta L mu 0, delta L tau 0. That means independently and separately all the lepton numbers, lepton type quantum numbers are conserved. So as it has no problem on any type of quantum number, this type of nuclear reaction is possible. Okay. So similarly, if I write here, I have just like that. Is it possible or not? You can see here Q has no problem. Q is -1, -1, 0, 0. B has also not problem. L, let me check L. L is what? L is -1. L is -1. This is 1. This is -1. This is also problem, not problematic, because -1, -1 and -1 as a whole -1, and this one is also -1. Energy is also not problematic because mu minus has energy 0.105 and this is 0.511. This has very neglected. So as a whole the energy is also fine. But this interaction is not possible because I have told you this is a weak interaction, right? And in weak interaction, Le, L mu, L tau should be separately and independently conserved. Let me check Le here. What is Le here? 0. This is 1. This is a nu E. Nu E means 1. Nu mu bar 0. You can see that this one is 0 left hand side, but in right hand side 1, 1, 0. That means 2. Delta Le is not equals to 0. Now coming to L mu also. Mu means 1. Mu minus is there, right? So it is 1. E minus 0. Nu E 0. Nu mu bar means -1. You can see the left hand side is 1 L mu and for right hand side it is -1. That means delta L mu is not equals to 0. So as delta Le and delta L mu are not equals to 0, that means that type of interaction is not possible. What is the interaction? The interaction is mu minus going to E minus plus nu E plus nu mu bar. That type of interaction is not possible because Le, L mu, L tau are not conserved separately and independently. Okay, this is a very important thing. For any weak interaction, we have to have the conservation of Le, L mu, L tau separately and independently. Okay. So I hope you understand this one, and I told something more on that also, but yeah, fine. So now coming to the question number 7. Is there any question till now? If there is any question, you can ask me, or otherwise I will go for the next one. I think no question. Okay. Okay, so coming to this one, which of the following pairs have identical valence quark content? So quark content. Okay, so for quark content of any particle, you have to remember little bit on that, because like there is no other option, other than remembering. So just little bit remember these two things. One is, first of all, there is one baryon docu-plate, you know, and baryon octet is there. So baryon decaplate is like that, and baryon octet is like that. Okay, so this is I3, this is Y, or sometimes we can plot I3 versus S also. This is I3, this is Y. So here you can see that in the decaplate, these 4, these 3, this 2, this 1, and here 1, 2, 3, 4, 5, 6, 7, 8. So there are 8, that means it is octet, and this is decaplate. So someone has written something or what? Okay, no. Yeah, so in that case you can see that our baryon decaplate is there, and in that decaplate 10 particles are there, and in each and every node whatever I have made here. And for octet also you can see that 8 particles are there, 6 will be in the corner, and there will be 2 particles which are very exact position as at the center. So in that case, like this plot is for spin 3/2 particle spin, and this plot is for spin half particle. Okay, but all are baryons. So what they are asking us, they are telling that the quark content of these four particles, among these four combination, which have the same quark content. So let me check at first n and lambda 0. Okay, just remember a little bit. N is where? N is here, P is here. Okay, and this is, let's say, sigma minus, sigma 0, sigma plus, and this is delta 0, lambda 0, something like that. So you can see here that lambda 0 quark content and n quark content are obviously different, and also we know the quark content of n is u d d. And for delta 0, what is the quark content? I also forget that one, I have to check. I just make one table for that, so that you can understand very quickly. Lambda 0 is there. Yes, lambda 0 is here. Lambda 0 is UDS. So if you write here UDS, this is the quark content for lambda 0. Then n is there, lambda 0 is there. So you can see here that UDD and UDS are not exactly same. That means the first option is not correct. N lambda 0 is not correct, which have identical valence quark electron content. Now coming to P and delta plus. Okay, so I told you here it is P, and what is this is delta plus plus, this is delta plus, delta 0, delta minus. So what is delta plus plus? It is UUU. This is UUD. This is UDD. This is UDDD, like that. Okay, as per I remember, I think I have written correctly. Let me check once. Okay, I think I did not mention here. Okay, fine, I think it's correct. So whatever it is there, see here, delta plus plus is UUU, delta plus is UUD. So UUD is delta plus, UUD, and obviously you all know that what is proton content, it is also UUD. Then you can see that UUD, that means delta plus and P, these two combination has a same, I mean identical, not exactly same, I can write identical quark content. Okay, so from that figure, from that question, I can mention here this one is right. I mean, which of the following pairs have identical valence quark content? This is P delta plus. This can have a identical valence quark content. Now coming to this one, lambda 0, sigma 0. Okay, I have already mentioned here, I think. Yes, you can see here that sigma 0 is also here, lambda 0 is also here. So lambda 0, sigma 0, what is the quark content for these two? Lambda 0 UDS, sigma 0 also UDS. So we can conclude with that lambda 0, sigma 0 is also have identical valence quark content. Now coming to pi minus, mu minus. Okay, that is a very simple okay. So this is a very simple thing, that pi minus mu minus means like one is lepton and one is meson. So if it is a lepton, that means there is no quark inside of that. Lepton means it is a fundamental particle, there is nothing inside of that lepton, right? So it is not made of with quarks. So obviously whatever mu minus is there is no quark, something like that, q bar or q like that, there is nothing. But for pi minus there is something as q bar. So whatever it will be the q bar, that is obviously not identical to mu minus. So for this question, D minus can all, I mean the D option, that means pi minus mu minus cannot have the identical valence quark content, because pi minus does not have any quark, so how they can have the combination. Okay, so for this question, so that means the answer of this question will be like B will be the correct one and C will be correct one. Yes, so P and delta plus and delta 0 sigma 0. Okay, so I have mentioned here some of the particles, some of the elementary particles. You can see here the particle name is in the left hand side. Then in the second column I have mentioned I and JP. I is what? I is spin. And JP is what? JP means J is the total orbital angular momentum, P is parity. And I have mentioned charge also, and I have mentioned strangeness quantum number. S is strangeness quantum number. Okay. So you can see here photon. Photon has I mean the spin 0, JP 1 plus, charge 0, strangeness, there is no strangeness because photon is not a strange particle. For proton, proton is half, spin is half, J is half plus, I mean parity is plus, charge is plus 1, strangeness is 0 because this is also not a strange particle. Similarly for neutron, half plus, charge is 0 and strangeness is 0. Now coming to delta plus, lambda 0. For lambda 0, I is 0 because and J is half plus and charge is 0. Okay, sorry, this I, this I is isospin, sorry, this I is isospin, I have to write here, this is isospin, and J is total angular momentum quantum number, and P is parity. So lambda 0 is 0 because there is no other family member in that lambda family, so lambda 0 is 0. Charge is 0, strangeness is minus 1. Because the quark content for lambda 0 I have already told, it is UDS, and if it is S, that means the strangeness will be minus 1. For U and D it is 0, right? But as it is S, that means it has a strangeness number minus 1. Now coming to sigma plus. Sigma plus is I has plus 1, I mean isospin is plus 1. Why? Because there are 3 members in that sigma family, 1, 1, 1. I mean all have the same I, but if I consider I3 value, so I3 will be here plus 1, this is 0, this is minus 1. Okay, now coming to half plus because J, P are half plus and all. Charge is plus 1, 0, minus 1, strangeness is minus 1, minus 1, minus 1 because sigma is also UDS type thing, so also here you can see that minus 1. Now coming to omega minus. Omega minus has the isospin 0 because it is only one member in that family, and 3 by 2 plus. Why 3 by 2 plus? Because it is in, I have told you na, this one, omega minus is here. So in that decaplate all the particle has spin 3 by 2, right? So the spin will be 3 by 2. Omega minus 0, 3 by 2 plus. And then what is this one? This is charge. Charge is minus 1. Fine. Now S, strangeness. So omega minus has a quark content S. That means it has minus 3 because minus 1, minus 1, minus 1. Fine. Now coming to pi plus. For pi plus it is I is 1. I means isospin. Why? Because there are 3 particles in that pi family. Pi plus, pi 0, pi minus. So I3 value is plus 1, 0, minus 1. Okay, now this is 0 minus, 0 minus, 0 minus, right? And the charge is plus 1, 0, minus 1. And strange means there is no strange particle strange quark present in that pi plus, pi minus, pi 0. So that's why the strangeness is 0. Now coming to k plus, k minus, k 0. Okay, so k plus, k minus, these two are making one family. So that's why it has half isospin. And if I am talking about I3, then it will be minus half and this will be plus half. And okay, so this is minus 1, plus 1. Okay, what is this one? Yes, This one is the strangeness number, this one is also a strangeness number, this one is strangeness number for k0, eta 0. Eta 0 has a 0 particle, I mean that only one member is there, so that's why it is 0. For omega 0, this is xi 0. For xi 0 and xi minus, there are two particles in that family, so I3 will be here half and this is minus half, and 0 minus 2 minus 2. But there here I have taken a mistake. This one will be like I made a mistake here, plus 1 plus 1. So okay, so this one will not be correct. These two will be one family, that means I3 will be here, I3 will be here, and this one will be 0. And this is not exactly a particle, this is the antiparticle of k plus only. So I should not write like that. Okay. See, basically for k state, I mean k0 and k plus, these two are basically in a family, k family. But k minus is the antiparticle of k plus, antiparticle of k plus. So it's fine, na? Okay. Now xi 0 xi minus, xi 0 xi minus is half of, because I is half of and I3 is half minus half, and this is I think charge, yes. For xi 0 it is 0, xi minus minus 1, and strangeness is minus 2 minus 2, because I think it is USS, something like that. Is it correct? One is USS, one is DSS, like that. I hope so. Xi minus DSS and yes, good. So this one is DSS and this one is USS. So you can see here that there are two types of S is there. So that means as a whole the strangeness number will be minus 2. Okay, now I have mentioned here the sum of the leptons. So you can see here that lepton is like electron, mu, tau, and 3 types of neutrinos. Here also you can see, okay, I did not mention here I value, because isospin means what? Isospin will be here nothing, and Jp is like half. Then okay, so this one will be J only, like the total angular momentum quantum number, and the charge is minus 1 minus 1 minus 1, and for neutrino 0 0 0, and strangeness there is nothing as strange particle, so that's why it is as a whole 0 value. I mean this type of things means it has a 0 value of strangeness number. Okay. Now coming to quark constituents, I have just mentioned some of the quark particle here, like particles and their quark contents. You can see here that k plus, k0, k minus, and then yes, you can see here, see, k plus has a quark content US bar and k minus has a quark content SU bar. It is nothing but the antiparticle of k plus, because US bar, and if I write here as a whole, let's say US bar as a whole bar, that means what? It will come as U bar S, I mean like SU bar, I have to write like that, SU bar. So SU bar is there. So k plus and k minus are antiparticle to, I mean they are antiparticle complementary, and k0 is ds bar. Now coming to pi plus, pi minus and pi 0 states, it is like ud bar, du bar, uu bar plus dd bar plus ss bar. And also eta 0 has the same quark content, eta star has the same quark content. Now coming to p and n, p is ud and n is udd, and then xi minus is dss, and sigma 0, I can write here xi 0 also, xi 0 is uss. Now coming to sigma 0 and lambda 0, it is uds. Okay, so this is the case. So I hope you understand this up to this point, that like I have just mentioned something little bit more on that quantum part, I mean elementary particle and their quark content as well as the strangeness quantum number. Okay. Now coming to the last question of our today's session. This is the last question, question number 8. In the decay of delta plus going to pi plus something, what is the missing particle here? Is it neutron? Is it pi 0? Is it proton? Or is it lambda 0? Okay. So I am just going to write like that, pi plus I am writing here as x. Okay, and x can be anything, and they have given 4 options. What are these? Neutron, pi 0, proton, neutron, pi 0, proton, lambda, delta 0. So first of all, what I need to do? I need to do B, Q and L check, right? And this is not a weak interaction, because you can see that there is no neutrino as an outgoing particle. So we will not check about Le, L mu and L tau and all these things, but we can also check the energy. That is also important. Energy conservation is also important, right? So first of all, we need to check B, Q and L. Let's say I am checking here Q value at first. So Q is plus 1, pi 0, pi plus has plus 1. So x should have 0. That means xb is 0. Because we have the decay, I mean that decay will be possible. So possible means delta B should be 0, and for delta Q should be 0. Sorry, this is with Q. Delta Q should be 0. So delta Q should be 0 means the left hand side and right hand side should have the same value. So left hand side has 1 value and right hand side means 1 plus something will be there. So 1 plus something means obviously it should be 0, otherwise these two will not be equal. So 1 plus 0 and then it is 1. So that means x of Q will be 0. That means whatever will be the particle as x, that will be a neutral particle. We have concluded from these things, right? Now coming to B. Delta plus is a baryon. Pi plus is not a baryon. X should have a baryon because 1 is there and these two can make 1. So x of B will be 1. It should be 1. Fine. Now coming to again pi 0, pi what? Pi plus, okay. Pi plus x. So we have checked B and Q. Now coming to L. This one is 0. This one is also not a lepton, that means 0. For x, obviously it should be 0. That means x of L will be 0. Good. So I have three properties I got. One is x of Q should be 0, x of B should be 1, x of L should be 0. So from these three conditions I can get a knowledge about x, that x should be baryon because it has xb equals to 1. It should be neutral because xq is 0. These two conditions I got, and it should not be lepton. Obviously if it is a baryon, then obviously it will not be a lepton. So these two conditions I got from that x. Now, and also from the energy conservation. Now I am writing right now energy conservation. What will be the energy conservation problem here? See, delta plus has a energy. It is like of the order of something MeV. I mean I forget that one, but yeah, like something is there in MeV, and yeah, this is well known. This is 140 MeV. So whatever it will be, we have to check that AM of delta plus should be greater than AM of pi plus AM of x, greater than equal to. That equal is also possible. So this type of condition should be there. Okay, so I got this condition also. This is the C condition because these two are A, B. Now coming to our options, whatever they have given neutron, pi 0, proton, delta 0. Okay, what they have given neutron, pi 0, proton, delta 0. So I told you that x of q will be 0. So x of q will be 0, that means neutron can be possible because neutron is also a neutral particle. Pi 0 can also be possible and lambda 0 also be possible. Proton cannot be a particle of x because the q value of x should be 0. So n can have, pi 0 can have, delta can have. Okay, from that first condition. From that second condition, the second condition was what? This should be a baryon. So now among these three, P has already gone because x of q equals to 0. So among these three, which one has the baryon number 1? Neutron is a baryon, pi 0 is not a baryon, lambda 0 is a baryon. So from that B condition I got two options, n and lambda 0, sorry delta 0. Now coming to C option. In that C option, what I told you, the C option means m of delta plus should be greater than m of pi plus m of x. Now I told you that there was a decaplet, right? In the decaplet, delta plus plus, delta 0, delta minus. In the decaplet, these four particles should have very similar mass, okay, because that's why they are in a delta family. So we got two options, one is n, one is delta 0. Now you can see, if I have delta plus mass which is very near to delta 0 mass, I told you that delta 0 mass is very near to delta plus plus or delta plus, okay. So these two masses are very near. Now you can have that m of pi plus is of the order of 140 MeV. So that means delta 0 cannot be a x particle due to energy conservation. Do you understand? Because this one is very similar to this one. So why this, how this type of heavy mass will come? Obviously it should be very greater than this plus this. So x cannot be a delta 0 particle. Then what is left here? N is left, neutron. So x will be n, x will be neutron. So whatever is the question, the answer will be A, neutron. So what I did here, I just simply checked B, Q and L property. From these B, Q and L property, I can have a conclusion that XQ will be 0, XB will be 1 and XL will be 0. So from these two I can have baryon number and neutral particle. So among these four particles, there are four particles, n, pi 0, p, lambda 0, sorry delta 0. So among these four, one has already gone, which is proton, by the first condition. By the second condition, xb will be 1, pi 0 has gone, that means two options are left, n and delta 0. Now coming to the third option, which is the energy conservation law. From that energy conservation law, I can say that x cannot be a delta 0 particle. Why? Because delta plus and delta 0 has a very similar mass, and if it has a very similar mass, then right hand side and left hand side will not be conserved, as there is a massive particle present in the right hand side, which is m pi plus. So the rest option is neutron. That's why we can conclude that x is nothing but a neutron. Is it understandable? I think yes. Okay. So if it is understandable, then I think we have already done today's class. So if you have any type of question, you can ask me right now. I'm just going to I'm going to show all of the questions today. This is the first question we talked about. Which of the following interactions are not influenced by electromagnetic interactions? And there are four options. and the correct answer is what is the correct answer? A and D. These two will not be influenced by electromagnetic interactions. Now coming to the second question. This is the second question. Pi minus goes to mu minus E minus E plus dk is not possible because of which condition? Energetic reasons, non-conservation of baryon number, non-conservation of lepton number, non-conservation of electric charge. And the correct one will be non-conservation of lepton number. Now coming to the next question. The decay of delta minus going to pi minus pi 0 is not permitted because of which reason? Energy reasons, non-conservation of baryon number, non-conservation of lepton number, non-conservation of electric charge. The correct answer will be non-conservation of baryon number. Now in the next question, which of the following reactions are not allowed? There are 4 options. Among these 4 options, A, C, D are not allowed and B is allowed. In the 5th question, we have 4 statements. Top quark, choose all the correct statements from below. Top quark is the heaviest elementary particle known to us, discovered so far. And the second one is baryons are made of 2 quarks. Third one is under suitable conditions, electron and positron can form bound states. And the fourth one is gluons can directly interact with photons. And these among these 4 options, A and C are correct one. Yes, correct statements. Now coming to the next question, E minus going to pi mu minus plus nu mu bar plus nu E dk is not allowed because of which condition? Energetic reasons, non-conservation of baryon number, non-conservation of lepton number, non-conservation of electric charge. The correct one is energetic reasons. Now the next question is, which of the following pairs have identical valence quark content n lambda 0, p delta plus, lambda 0, sigma 0, pi minus, mu minus. So the correct answer will be B and C. P and lambda 0, delta plus. Okay. Now the last question is, in the decay of delta plus going to pi plus plus x, what is the missing particle? And the 4 options are neutron, pi 0, proton, delta 0. Sorry, lambda, delta 0, yes. Now the correct answer will be neutron. So up to this we have done. If you have any question, you can ask me.
Ma'am?
Yes.
Ma'am, I had a question of previous day's assignment which we discussed yesterday. Actually, I was not present yesterday.
Okay, fine, no problem. Yeah.
And there was a question, ma'am, it was on the cross section, differential cross section of a reaction.
Yes.
Found to be named one.
Yes.
That particular question was not present in the recording. For some reason, that was not recorded.
Yes.
I did not. And when I saw the recording, actually, I did not understand how that question was done. Ma'am, can you please discuss that?
Yes, sure. Actually, I don't know at that time how recording has stopped. So I was just did the recording after some time. I mean, at that time when recording stopped, I did not understand. Okay, so when I understood that okay, the recording has stopped, at that time I started the recording again. So I think that portion for that cross section portion, the recording has lost. So yeah, that's why you could not find the recording. Okay, I can tell right now also. Let me give some space for that. Okay, I am just going to share that question so that it will be helpful. Just a minute. This is 5th question. Okay. So that one was the question for the previous year, and Which question you were asking? You are asking about this question, I hope. Let me see. Yes, this one.
This one.
Okay, so I am not going to write these things again because it has already written here. Okay, so whatever I will tell right now, it will be recorded, so you can see later also from this week. Okay, so this is the question. The question is, the differential cross section of a reaction is found to be d sigma d omega is 1 plus cos theta. In a specific experiment to study this reaction, the projectile beam prepared with flux density 10 to the power 25 particles per centimeter square per second was sent to a fixed target. A cylindrical detector is placed with its axis along the axis of the beam on the opposite side. The detector D1 spans an angle 15 degree with the target as the center. It detected 432 particles in 30 seconds. When it is replaced by another detector D2 spanning 30 degree, how many particles would it detect in 30 seconds? And there are 4 options for that: 113, 455, 864 and 1656. The correct answer will be D, but I will tell how to do that. So first of all, in that question what they have given the values d sigma d omega, which is 1 plus cos theta, and also they have given let's say flux density. Flux density they have given 10 to the power 25 particles per centimeter square per second. They have also given 2 detectors information. What type of information they have given? They have given that the first detector, which is D1, it is at the angle of 15 degree with the target as the center, and it detected 432 particles in 30 seconds. And for D2, which is placed at 30 degree angle with the target as the center, how many particles would it detect in 30 seconds? That is the main question. So for that, what we will do, I have made a picture here, but I think due to the space I removed that picture. Okay, I am going to so here let us consider one particle is coming here, and it is coming and it is striking in a center of a hard sphere or something, you can tell, and I have, okay, not like that, just a minute, the picture is not correct here. Yes, so let us assume that I am going to send this particle to a target, and the target has a center and it has a circle like that, and we are going to detect this particles, number of particles, how many number of particles we will detect, and the particle detection will be at D1 at the very first, and the D1 is like 15 degree angle from the axis, I mean beam axis. So this is the case for the first one, and in that case 432 particles were detected. Okay, and this is 15 degree angle, but they are asking that what will happen if I will place that detector D2, which is 30 degree angle from the beam axis, and for that how many number of particles will be detected in the detector? That is the question. So it is already given that 432 particles are detected in D1. So how many number of particles will be detected in D2? That is the question, and the detector D2 has an angle 30 degree and the detector D1 has the angle 15 degree. So only the difference between D1 and D2 is like the angle, nothing else has the different. All the things are same. So what I will do at the very first, I am just calculating one expression. I am writing one expression. What is the expression? This is the ND1. ND1 means number of particles detected at the detector D1. So this is the number of particles detected at the, oh, someone is there. Okay. So ND1 is number of particles detected at the detector D1. So what will be the value of ND1? ND1 is okay, I have written full expression. Yes, this is the expression. ND1 is nothing but the flux. This is F, means this is the flux. N is number of target nucleus, delta t means up to how many time we have detected. In that question you can see that up to 30 seconds we have detected, right? So flux is given, delta t is also given, n means number of target nucleus, this is one target nucleus, okay. And then this is the expression, means d sigma d omega into d omega. So d sigma d omega means what is the cross section of the particle beam, and d omega is the solid angle made by the detector. So the full expression for nd1 is f n delta t integration over theta and phi d sigma d omega, that is the full expression. So now we can have data that d sigma d omega is 1 plus cos theta, and d omega is the solid angle. So solid angle can be written as sin theta d theta d phi. I have already mentioned how to calculate d omega as sin theta d theta d phi. You can see d omega means solid angle. Solid angle is nothing but area divided by r square. So area for that detector is r square sin theta d phi, because we are considering in polar coordinate. In polar coordinate dA is r square sin theta d phi, and it is divided by r square. That means as a whole it will be sin theta d phi. Okay. So d omega sin theta d phi. Now we are just going to put these values here in that nd1 expression. nd1 is 432, as I already told, it is already given in the question, 432. That is equals to f into n into delta t into double integration. Double integration means one integration will be on theta, another will be on phi. Phi is azimuthal angle and theta is at which angle it is placing with the beam of the axis. Axis of the beam, axis of the beam. So here d sigma d theta is 1 plus cos theta, I have already mentioned, and d omega is sin theta d phi. Then what we will do, we will just simply integrate that one. In that integration you can see there is d phi is there, and d phi is not present in this case, phi is not present in that calculation. So we can totally integrate d phi independently. That means d phi will come as 0 to 2 pi was there, so that means 2 pi will come in the front. So 2 pi f n delta t, and then integration over theta 0 to 15 degree. As for d1, 15 degree was the angle, 1 plus cos theta sin theta d theta. Now I am just going to put the values here. I think it was mentioned here somewhere. Yes, you can know here. You can see sin theta 1 plus cos theta d theta. Then sin theta 1 plus cos theta d theta means what? Sin theta plus sin theta cos theta d theta. So sin theta d theta means minus cos theta, and then sin theta cos theta means half of 2 into sin theta cos theta. So 2 into sin theta cos theta means sin 2 theta. So if I write sin 2 theta integration, then it will be minus cos 2 theta by 2. So as a whole this is the integration result, and we are going to put the limit from 0 to 15 degree. Good. Then we are just writing this one as it is, and then we are just putting at the very first 15 degree, then 0 degree. So if I put here 15 degree, then minus cos 15 degree, then minus plus, and cos 0 is 1. Now it is minus, 1 by 4 I have taken as outside, then in the bracket minus cos 15 into 2 30 degree plus 1, because cos 0 is 1. So I have written here like that, and this is nothing but equal to 432. Good. Now they have asked me nd2. They are not asking me nd1, but they are asking me about nd2. nd2 is what? nd2 is exactly similar, that 2 pi f n delta t. Integration will be different, just 0 to 30 degree will be there, and all the things will be same. So now what I will do, all the things whatever it is there, 2 pi n f delta t, you can see that this type of things are there, and we are just going to replace this value by this value. So what will be the value for that? 432 divided by this whole portion. So I am just writing that one, 432 divided by whole this, and then I am just doing that integration about 0 to 30 degree. So I am just doing that integration, and we are just doing some calculation on that, and then we can have a result that 1656. We have already calculated yesterday by calculator, so that we can get that type of answer 1656. Do you understand, or is it a little bit fast for you?
No, ma'am, I understood.
Okay, so that type of thing we did. Like at the very first we explained how ND1 is coming, and then from that ND1, where is that ND1? Yes, how ND1 is coming we have understood, and after that we are just putting all the values whatever it is given in that equation, I mean whatever it is given in the expression. Then after that I am just writing here ND2. ND2 will be just a replacement of ND1 this term, and then there will be a integration 1 plus cos theta sin theta d theta integration 0 to 30 degree, and we can have a value of the order of 1656. You can see that I have exactly calculated and it was coming as 1655.7. So we can we can preciously see that it is nothing but 1656. So, and you can see here there is one option as 1656. So that's why it is the option number D. Now in the next question, the similar question was there. In the above question, how many particles would be detected by D1 when the flux density is doubled? Okay. So what was the expression here? The expression was this one, whatever we have written. So you can see they are asking that if I have doubled the flux density, what will be the number of particles detected by D1? So previously what was the number of particles detected by D1? 432, right? So, and right now by that expression we can see ND1 is linearly proportional to F. I have written here ND1 is linearly proportional to F. So if F is transformed as 2F doubled, then obviously the number of particles detected by the D1 detector will be double. That means 432 into 2, which is 864. So the correct answer will be 864, which is option number 3. So up to this we have done previously, I mean yesterday. Do you understand?
Yes, ma'am.
Okay. So anything you want, like from this yesterday? I think all the things I have already recorded, but that one was not recorded. So yeah.
Yes, ma'am.
Someone has written something or what? Okay. Ma'am, is it possible to see the last week's problem solving session? Last week problem solving session, last week means you are talking about week number 5, right? So if it is week number 5, yeah. So in that week number 5, I did that week number 5 as previous year question assignment solution yesterday only. So you can see from my YouTube channel also it is there. So I have just recorded and I just uploaded that in yesterday YouTube channel. I mean, you know, my YouTube channel is there. So in that YouTube channel you can see there is the lecture is there, recorded version. But the main problem was that there were a small portion of the recording part which was missed. So that's why someone asked me to answer the question again, because I did not understand that at which time the recording has stopped. So that is the thing. You can see that from my YouTube channel. Okay. Okay, so anything else you want? I'm just going to show you these two again. So this I can modify and I can send to the drive again, so that you can have the access of the PPT also. And this also I will just share. This one is the previous year, I mean that week 5, and this is week 6. So anything else you have to tell me, or any comment?
Ma'am, your channel name in YouTube.
Okay. Yes, so I'm just going to show you. Just search here YouTube. Yes, then nothing you have to do. You have to yes, you have to just search my name here. If you will search here, then you can see here nuclear and particle physics NPTEL week 5 is there. So you can see that the timing was also very small because there was a little bit disconnection was there, so that's why. So here you can find all the problems like week 4, week 5, week 3, week 2, all the things are there. Okay. Okay, so is there anything else? Or should we stop the today's session and we will meet again? Oh, something is there. Oh, thank you. Welcome.
Thank you, ma'am.
Welcome. And we will meet in the next class. The next class will be on next Sunday. Yeah, next Sunday, 3 to 5. Okay. And in the next class, we will discuss about week 7. Yeah, week 7. Okay, so for now, bye bye.
Bye, ma'am.
Bye bye.